Today we're going to continue on with the method machine packet. So for today's notes, we're going to do kind of the middle section of this. We're still not going to finish it with this video, but you're going to need this packet that you should have filled in the first 2 pages from the last video. You should also have this chart. It's called the ASCII, ASCII code table. So if you don't have that, make sure you pick that up before you start really getting into this lesson. But if you're ready to go, let's move on. We were on example 4, and right away you're going to need that chart. Okay, so it says define a method which converts a lowercase character to its uppercase equivalent. So if I give you little a, I want to return capital A. And this concept is probably the trickiest thing we're going to do today. So I'm going to spend a little bit of time just kind of talking you through this. So I'm going to put a note up here that we need the ASCII chart. And basically what that is it's a chart that assigns a number to all the characters that you can type from a keyboard. And people ask every year what ASCII stands for, and I always forget. Something about American Code Interface System. There's actually a question on Jeopardy not too long ago. But anyways, if you look at that code, we're interested with the capitals to the lowercase. So like given lowercase a is assigned the number 97. Capital A is assigned the number 96. All we're really going to care about is what character we're looking at. So I'm kind of looking at these columns and what the number equivalent is. So we've got little a is 97 and big A is 65. So let's make note of that. If we have little a equals 97, then capital A equals 65. And let's look at the next one. Little b is 98, capital B is 66. So little b, little b is 98, capital B is 66. And you technically don't need to memorize this chart. If you ever need to refer to it, I'll let you look at it. But generally, you shouldn't actually need it. And I'll show you why later on. But for this scenario here, what's true about all of these differences? If I'm going from little a to capital A, or little b to capital B, how many numbers difference am I going down? It's always a difference of 32. So that's going to matter for us, and that's how I'm going to write this program. So public char, remember these are non-void methods, so I'm going to return an uppercase character. So that's why it's a public char. It's called lower to upper, and I'm given a lowercase character, so that's why I have char ch as a parameter here. Okay, so we're going to do this 2 ways, just kind of like I was talking about yesterday. I'm going to make it temp variable. This time it's a char though. And you can call it temp. I decided to call this one upper. Stand for the uppercase. And let's just make sure they're actually giving us one of those values between A and Z. Now I could say, I could check if the character that's given to me is greater than or equal to 97 and less than or equal to 122, because that's what Z is. But the nice thing is we don't have to know those numbers, and that's why I said you don't have to memorize it. If you want to say you're between A and Z, you can say if the given parameter, so CH, if that's greater than or equal to A, little a, we have to put that in single quotes because it's a character, and, remember how to say and, the double ampersand, and that character CH is less than or equal to Z, then we know I'm at least actually given a lowercase letter. And just as a side note, I could also write if CH is greater than or equal to 97, and CH is less than or equal to 122. That means exactly the same as what I wrote in blue over here. But really, you probably wouldn't do this ever because then you'd have to memorize what little a and little c's ASCII numbers are, and I don't usually know those either. Okay, so anyways, if we're between there, we want to change it to its uppercase equivalent, which is always a difference of 32 away on that ASCII chart. So what we can do is we can set upper equal to, now leave yourself a little space, I'm doing this on purpose, CH minus 32. Because whatever CH was is a lowercase, 32 away is its capital equivalent. Okay, now I put a space here on purpose because we have to do something else, and this is why it gets kind of annoying. I'm going to put another note over here. Doing math turns a char into an int. So doing math, so adding in this, or subtracting in this case, doing math to a char changes it to an int. So we need to get it back to a character. We need to get it back to a character. Back to a char. So what I do to make it that CH minus 32 a char is I cast it as a char. So anytime you do math to a character, if you want it to still be a character, you've got to cast it to a char. And we also need a set of parentheses right here because you have to think order of operations. We got to change CH minus 32, do that first. So 97 minus 32, for example, is 65. And then if I char 65, that takes whatever 65 is and changes it to its character equivalent, so now it's back to A. So that's what the code should look like. And I'm going to show you an Eclipse real quick, just so you can get an idea. So let's say I start with char lower, or let's even use CH like we did, equals, let's say little c. So right now if I do system.out.print ch, waiting, there it is. There should be no surprise that I see a C printout. So when I run this, there's a C. Nothing crazy there. Okay, so now if I say char upper equals CH minus 32, there's an error. Look at what the error is. Tight mismatch, cannot convert from int to char. So it's saying this is an int, you're trying to make it a char, that's not okay. Because doing math to a character, math in this case being minus 32, changes it to an integer. Look what happens if I just ask it to print that out. If I print out CH minus 32, I get 67. It made it an integer. If I cast that as a char instead, and then print it out, we'll look at your chart. What's 67? Capital C. When I run it now, I get capital C. So hopefully that illustration makes a little bit more sense why we have to cast it as a char here. Anyway, let's finish off this this method here. So that's if it was a lowercase character. If it's not a lowercase character, what do you think we should do? Well, I can't say error because I still have to return a char. So let's just make upper equal to CH in that case. It's not going to do anything. So if it gives me something like exclamation point, then I'm just going to return back the exclamation point again. Okay, remember from yesterday, what's the last line in here need to be? Since it's a public char, we have to return a character. And what character do I want to return? Upper. So return upper. All right, that concept is a little tricky, but it is going to be useful in a lot of programs that we do going on further. So if you have any questions on this, please pause the video and bring me over right now, or write a note to have me come help when you get back to class. All right, number 5 should be a little bit easier. Define a method which will return the area of a rectangle given it its length and width. Why don't you try this one on your own? Think about what type of method it would need to be. You don't need the ASCII chart or anything like that. We're going to be given a length and a width. So those would be your parameters. And length and width could be decimals, so take that into account. It's going to return the area. So pause this video and give this one a shot. Write the whole method heading. You technically can do this in one line. So see if you can write this in only one line. When you're ready to check, press play on the video and I'll show you how it's done. Did you press pause and try it? If you haven't, don't forget, I'm going to find out. So do it. But if you have, here we go. So this is all you need to do. It's going to be a public double because I specified a second ago that the length and width could be decimals. So that means the area could be a decimal either. You got to name it something. You could call it rectangle area or I just called mine area. But whatever you called it would be fine. And you should have 2 parameters. One, because it's given its length and its width. So both of those could be decimals, so both of those need to be doubles. So you need double length, comma, double width. And even though they're both doubles, you have to write the type for both of them. So make sure you wrote double for length and double for width. And you could make a temp variable and then return the temp, but I said you could do this in one line. All you really need to say is return length times width. And that's it. That's the whole method. If you put parentheses here, that's totally fine. Sometimes it even looks a little bit cleaner if you do that, but you don't need them. Okay, so I told you yesterday that you always have to do something with a non-void method. If something gets returned, you have to do something with that. So I wanted to give you some examples of how you could use or call this method. So if this method was written later on in the program and you wanted to use it in a later method or call it from another method, you could obviously set it equal to a variable called area, or you could even put it in an if statement. I could say if area 5 comma 7 equals 30, system.out.print true. And else system.out.print false. Now, if I were to run this block of code right here, what do you think would show up in the output? Well, again, area is the name of this method. And I'm sending it 5, so 5's the length, and 7, so 7's the width. So this right here tells it to do this code. It returns the length, which is 5, times the width, which is 7. 5 times 7 is 35, and 35 gets sent right back to where this method was called. So this essentially means 35. And then the method or the code does something with it. 35 is not just floating here, it's checking, is 35 equal to 30? It's not, obviously, so the else is going to happen. So if you were to run this code, the output would be false, because the area is not equal to 30. All right, let's go on to the next page. Example 6, determine a method which determines the sign of a real number. Returns either a positive sign or a negative sign. So for the purpose of this question, let's just say 0 is a positive number. It's not really positive or negative, but just to make things easier. So think about what type of method would this be? If it's going to return a positive sign or a negative sign, what would a plus or minus be? What type of variable? Hopefully you're thinking a char. It's not a number, positive and negative. It's really a symbol, plus or minus. So I'm going to say public char, what do you want to call it? Sign? Sure, that's what you want to call it. And is it given any parameters? Determines the sign of a real number. So when it says a real number, assume that that means a decimal. Real numbers could be anything that's not imaginary. So it could be a decimal. So we're given a double parameter. Call it double number. And again, I could do this without a temp variable, but I'm also going to have to decide if it's positive or negative. So I'm definitely going to need an if-else. And sometimes with those, it's almost cleaner to just write in a temporary variable. So I'm going to make a char variable called value. And if that number is greater than or equal to 0, I want that value to be a plus sign. So we're going to say value equals plus. Now there's something else I need on this line to make it work correctly. Any idea what that is? We haven't done a lot of character values lately, but whenever you set something equal to a char variable, you need to put single quotes around it. So plus is a char, we need single quotes around that. So otherwise, if it's not positive, it's got to be negative. So value would equal to negative. But then don't forget, what do I still need? The public jar, not a char, not a public void, so I have to return a character. So what character do I want to return? I want to return whatever character is stored in value. So we're going to return value. That's it. Now we can make this better. We can maybe return positive, negative, or 0 if it's 0. We just use an else if in that. And 0 is a character. If you look at your ASCII chart, if I wanted to return character 0, it means the number 48, but I could return the character 0 also, and it would still look like 0. But this is good enough for us. Just another example of how you could call it, maybe. And again, the calling isn't really part of the notes. Like if this was a question on a test, this is all you would write. I'm just trying to give you ideas of how you can see these non-void methods being used. Let's say I wanted to keep running something while the sign of a number was positive. I could put this right inside a while loop. I could say while the method sign, sending it some variable called num, is equal to the positive symbol, keep doing some code. But this counts as doing something with it too. It's saying run the method called sign, sending it the variable num. This code will happen. I'll get either a value of plus or minus back. That will get sent right here, and it will be compared to this plus symbol. If plus is equal to plus, it'll do the code. If it gives me back a negative symbol, it's not equal to plus, so it won't do the code. But again, just get that notion that you have to do something with what's being returned. You can't just write this without anything after it. Okay? All right. Over to example 7. Next page. Define a character which determines whether 3 char variables contain the same character. This function returns a Boolean value. So I've already got the method definition for you. It's public Boolean, same. And Boolean, you could think of Booleans like a char. Booleans are only going to be true or false. Technically, the number 0 is assigned false, and the number 1 is assigned true. So you can compare true is greater than false, technically. Anyways, that doesn't really come into play here. I'm given 3 characters, and I only want to return if it's true if those 3 characters are equal. I'm actually going to start with this down here, the alternative but less desirable method, because it kind of makes more sense. Same thing, I want to check if character 1, character 2, and character 3 are the same. So maybe it would make sense for you to do an if-else. We could say if character 1, ch1, is equal, so double equals, to character 2. And what else would I need to check? Character 2 is equal to character 3. Do I need to check also if character 3 is equal to character 1? Technically, it already has to be. This is called the law of, I think it's modus tollens. You probably haven't learned that yet. But if 1 is equal to 2 and 2 is equal to 3, it's always true that 1 is equal to 3 also. It's kind of just like a substitution. You can plug that in here. So that's all you really need to check. And if that's true, we can return true. Oops. Misspelled return. And true is actually a word that pops up purple in Eclipse also. You don't have to put it in quotes or anything. If that's not the case, we want to return false. Now remember I said you got to be careful when you're returning in if-else statements. You just got to make sure that you're returning something in every case. And since there's an if or an else, one of these is definitely going to happen, and both have a return in them, so that's fine. Now the tricky thing is we can actually do this in one line of code also. The answer to an if statement is actually a Boolean. So this right here, this answer is true or false, which is a Boolean. And that's a little bit hard to think about, but it makes sense if you really think about it here. ch1 is equal to ch2, and ch2 is equal to ch3. That's either true, that is the case, or false, that's not the case. If it's true, we want to return true. If it's false, we want to return false. Well, why don't I just return whatever this statement is? We can do that in one step. So if I just write return ch1 equals ch2 and ch2 equals ch3, that does the exact same as that if-else statement I did at the bottom. So if this makes sense to you, use it. It's a lot quicker, it's a lot cleaner, and it's a lot more advanced. If that totally blows your mind, just keep doing this. It does the same thing and it'll work. All right, let's talk about calling this one. So a calling example, how you could use this method. We could put it in a system.out.print because that's doing something. I could say system.out.print. The method was called same, and I was supposed to send it 3 characters. I can send it 3, 3, and 5. Even though those look like integers, you can think of those as just the symbols. Those are also characters. They show up on the ASCII chart. Character 3, character 5. What do you think would print out? Well, same 3, 3, 5. Character 1 is equal to character 2, but character 2 is not equal to character 3. So this statement is not true, so it's going to return false. And in Eclipse, the output is going to say false. Back in the day, I think it would say 0, but I think they've updated it, so if it's a Boolean, it actually says the word false now. Okay, let's do one more page for today, and then we'll call these notes done. Example 8. Define a method which returns the sum of the consecutive integers between 2 given integers inclusive. So what does that actually mean? Well, let's say I give you the numbers 2 and 5. What I want this method to do is start from 2, add 3, add 4, add 5. So inclusive means including the start and ends. And I take every consecutive number in between, add it together, get one answer. This is 5, 10, it's going to give me 14. that's what it's going to return. Or if I gave it -1, 3, we'd take -1 plus 0 plus 1 plus 2 plus 3. What would be returned? 5. Okay. Well, what do you think I could do? I've got the method header here. It's going to be a public int because I'm given integers. Adding integers are going to still be integers, so my result's going to be an integer every time. I have two parameters, my start and my end. Like 2 is my start, and 5 is my end. What could I use that would start at that first value and go all the way to that second value, incrementing by 1 as I go? Hopefully you're thinking of for loop. I also want to keep adding on the next number every time. What do we know that we can use that keeps adding on? Hopefully you're thinking accumulator. So those are the two things we need. Let's start with our accumulator. Int total, I'm going to call it. And initially, what should that equal? 0. Remember, it's a good idea to always initialize an accumulator value. Okay, now I want to start from this first digit. So my for loop is going to start with int I equaling whatever that start value is. I want to keep going as long as I is less than or equal to what? Whatever the second number is, end I plus plus. And what's the one line that needs to go inside the for loop? Well, I want to accumulate on the next value onto total. So total is the accumulator, so we should have total plus equals what? We're going to start with 2, then go 3, then go 4, then end at 5. What variable is holding 2, 3, 4, 5? It's I. So after that for loop, my answer is in total. What's the last thing I need? Return total. All right, let's do a couple calling examples off to the right here. What would the output be if I said system.out.print sum 410? Well, it would run sum, start values 4, end values 10. So it'd be 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. What's that going to be? That's 10, 20, 25, and 15 is 40, and 9, 49. So my output would be 49. And it does something with what's returned. 49 gets returned right here, which is inside of system.out.print, so it does something with that 49. It prints it out. What do you think would print out if I said system.out.print sum, let's say 8, 4? You think it'd be an error? Not exactly. So if I start with 8 and end with 4, total is going to get initialized to 0. I starts at 8. I'm going to run as long as 8 is less than or equal to 4, which it never is, so it's just never going to run. And I'm going to return total. So what's going to get returned? Well, total was 0. This never happened. It's going to return 0. So that's going to say 0. So if you do it in the wrong order, you'll get a 0 back. Okay? Any questions at all up to this point? If anything hasn't made sense, hope you paused the video and asked me. If not, do that now. Because I got one more and I want to see if you can do it today. This one's a little tricky. Define a method which returns the decimal part of a real number. So for example, if I call the method fraction and give it 45.268, I would just get 0.268 back. Here's another example. If I gave 28.52, what would get returned back? Just 0.52. So it's going to be a public double for sure because it's returning back the decimal part, so it's got to be a public double. It's given a number that's a double, so that's why the parameter there says double. See if you can write some code that would always give the decimal back. Why don't you pause it, think about it for a few minutes. This one isn't as intuitive, as straightforward, so you might need a few minutes of thinking, but I really want you to think it out, write something down, and see if it works. So pause the video right now, take at least 3 to 5 minutes thinking about it. Go ahead. Pause it. All right. I'm assuming if you're watching this part of the video, you've worked on this for a few minutes. If you have something down that doesn't match what I show you, doesn't mean it's wrong. And if you want me to come over and check to see if yours would work, I would love to do that. So why don't you have me, actually, why don't you do that? Have me come over right now and check off what you wrote before you write this, and then I'll know if you actually did this. Okay, but here's how you do it. So essentially, what I need to do, like with 28.52, how do I get 0.52? Well, I take 28.52, I minus 28, that gives me my answer. Same with 45.268. I started with the 45.268, take off the 45, and I get my answer. I always want to take the integer part of the number off. So if I have a double and I want to make it an int, I can cast it as an int. If I wrote int in front of 45.268, it would just lop off the decimal and say 45. Knowing that, I can do this in one line. I can just say return whatever my full number was that I was given, that's my parameter, minus the integer parts, so cast number as an int. So the full number minus the integer off of it is going to give me the decimal that remains. That's it. Ease peas. Actually, that's pretty confusing the first time you see it. So if it's not ease peas to you and you'd like me to come over and explain that, please raise your hand now or write a note so that I can check it first thing when you come back to class. But we're going to stop there today. Save that ASCII chart and this packet. You're going to need both of those for the next video as well.